All right. Hello, everyone. There was a little break last week. We didn't have any lesson, but this week we're gonna learn a lot of stuff, a lot of cool stuff. Most importantly, we will go through LINQ, Language Integrated Query. We will learn how to process collections, basically things that have multiple items in it, containers of multiple items, for example, a list, an array. We will learn how to process both of them in exactly the same way. That's LINQ. We'll also learn what are generics and how to make one yourself. We will learn how do you make a choice, what collection to use. We'll learn more about collections. On top of list, we will also learn about dictionaries. And lastly, we'll try to make our own LINQ. We'll try to create extension methods and illustrate how LINQ works. So let's get to it. Before we start, it's worth analyzing what we have so far. We have this shopping list controller, which basically calls a bunch of services. That's what a controller is supposed to do. So it doesn't really do anything by itself, and therefore we won't be touching it today. We'll be focusing on different things, lower level things. I will go to services and see what we have there. This one is boring. We won't be touching it. Shopping list service is a cool one. Tax shopping list converter, tax policy. Right. Well, essentially, this one is probably the one that is the ugliest of all, that really has a bunch of stuff that isn't properly implemented. Why is this class so clunky and ugly according to me? Well, because it has loops. So many loops. Basically, in every single method, we have a loop. And instead of a loop, actually, we can write something known as LINQ, a query syntax-based method. So instead of doing something like this, I can summarize this in a single line using LINQ. So I can say shopping lists, and now I will state what do I do with those shopping lists. LINQ allows me to chain things. For example, right now I will first select the cost of a shopping list. I will shorten the name with SL. That's okay in here. And that's what we do with that shopping list. We calculate total cost. Next, we want to sum that total cost. And that's really all. So instead of all those lines, using LINQ, it can be summarized to just these two lines. Let's try to understand what is going on with this shopping lists collection. List is a collection. It holds something, shopping lists, many shopping lists. And here I first selected total cost of a shopping list, and I do the same for every shopping list in shopping lists. And the total cost results in a decimal. So here I have an IEnumerable, and then if I call sum, IEnumerable of decimals. So if I call sum, it sums all those decimals, all those total costs of individual shopping lists. And the resulting thing is a sum of them. And that's basically the equivalent thing, but written in LINQ. You might be terrified with this symbol. What does it even mean? It looks like an arrow, right? But you don't know yet. So this thing actually is a function, a nameless function, a function that you can make on the fly. So this whole thing is a function. This whole thing is a function that tells me what am I selecting. And here I say, for every shopping list, calculate its cost. So this whole thing is a function that allows me to calculate shopping list costs. So by passing this function in a select statement, I'm saying for every shopping list, calculate its cost and return that to me. And when it returns that to me, I'm still working with a collection, but no longer a collection of shopping lists, but a collection of prices, costs. And then what can I do with costs? I can sum them, for example, or take average, and so on and so forth. So this is how the first method was refactored. Let's move on to the next one. Lookups are super simple with LINQ. But this one is quite different. Why is it different? Well, it's not different, actually. So this one is an interesting one. I'm actually not sure what does it do. Why is it not used? Let's delete it and move on if it's not used. Find shopping list, a perfect case for LINQ. Basically, once again, this will be a single line. Filtering is very easy with LINQ. Basically, what am I doing here? As the name implies, I'm finding something. So I'll say find, or rather first or default. So it will basically return first element in this collection that matches this condition. So I'll say list. So if the ID that we have here matches the ID of any shopping list, it will be returned. And that's literally what we're doing. So it becomes just one line, and I can remove this whole thing with the power of LINQ. Here, it's pretty much the same, but it involves validation, so no loops. There are no loops, so it doesn't matter. We don't do anything here special. It's not a loop, so LINQ is not applicable. That's basically a logical conclusion you should make when like even coming to a realization if LINQ is applicable or not. No LINQ, no loop, no LINQ. And that really is all that we could refactor for this one. This is a loop, but it's a small and tiny one, and it's fine as is, I guess. So last time we had a brief look at extension methods, at methods that allow us adding behavior on things that don't belong to us. For example, in here, we add a behavior to capitalize first letter for a string, something that we don't really own. And yet, from a string, we can now call this method. For example, in here, I could call capitalize first letter, as if this was always a part of string. And understanding extension methods really is a key to understanding generics as well. Not generics, but LINQ, because LINQ is based on this. Let's create an extension method. But before that, a question. Can't we refactor get by name method? Let's see. There is no such method, but I deleted it. So I can add it back. Let's do it. Let's refactor it. So get by name. Right. So once again, we can do a one-liner. And what do we want here? We basically say take shopping lists and filter those shopping lists where names are matching. Well, this basically means where list shop name equals to this thing by ignoring case. For complex LINQ, I move LINQ to a different line. So once again, a single line instead of a big loop. Very easy. LINQ is really easy. It's just a habit that you need to get yourself into. Every LINQ, well, most LINQ, at least the ones that return collections, will always return IEnumerable. And here is why. If we go to extensions, let's create a new extension. I'll call this extension IEnumerable extensions. And before we proceed, what is IEnumerable? You know, IEnumerable allows us to abstract away the underlying type of a collection. It's an interface that all collections have to implement. And basically, it means you can enumerate through me. In other words, it means that anything that is IEnumerable can be put in a for each loop. Let me illustrate what I mean. If we go to our controller, for example, definitely an awful example. If we go to a shopping list service, for example, here, get shopping lists. This is pretty bad because if we do this, we allow adding to this list after we get the shopping list. So it basically leaks implementation details, and it allows for people to do things that they're not supposed to do. For example, I don't want people to allow adding stuff to these shopping lists. Not directly, at least. I want them to use my methods. If I allow this kind of behavior and exposure, I basically allow anything. Anything that can be done with a list will be doable with a shopping list. And a quick fix for this would be simply changing the type from a list to IEnumerable. And as always, IEnumerable is something that works for everything, for every collection. Nothing changed, but my intention is 1,000 times more clear. By changing the type from list to IEnumerable, I say you cannot change lists directly. Do it through the shopping list service. All right, so let's go back to IEnumerable extensions. What was I on about? Once again, extension methods need a static keyword. And we will have an extension method that allows us to print all elements in a collection. Sometimes it is useful. It's often useful for debugging purposes as well. So I'll say to string, but a different kind of to string for many. Like convert a collection of anything into string. Now, let's say we want it to be printed like this. Like this is first item, this is second item. So one item in a line. Fair enough. What I can do now is, again, do a LINQ. This needs to return a string. So I first need to convert these items into string. So I select, because I need to map from one thing to another. And then now that I have a bunch of strings, I need to join them. And join them like this. And this is what I return. What's wrong? Did I mix the parts? Yes, I did mix the parts. Yeah. So I basically say, take items and convert them to a string. Each item, convert them to a string. And then join all those items by comma. So sorry, it will be printed like this now. And I can say in the end dot. So this literally just separates each item of any type and converts them to a string and separates that by a comma, basically. And I did this in one line, more or less. That's the power of LINQ. What we have here is called a generic function. A generic function allows me to push away a decision of specifying a concrete type until it's necessary. When is it necessary to specify the type, you might ask? When I call a function to string many, I can specify the type. For which collection am I calling this to string many? Let's test if this function works. Always test what you write. So I will call this IEnumerable extension tests, and I will say I don't know how to call it yet, and I'm using XUnit. So it's a theory, and let's specify a bunch of scenarios. We will be using member data. And I'll call this to string many expectations. And I will create a property which supplies this test with data. Like this. And I will say it's a getter. And I will also say yield return. I won't say that. Now I need to create test cases. So the first test case will be if I have a single collection, a collection with a single item, or rather an empty collection, what should be printed if I have an empty collection? Or a null collection as well. So let's say of integers. Doesn't matter with what generic type we work. Right. Null. So if we have null collection, we will have just a dot printed. I've got new. So here I'm basically saying this is my first scenario. This is how you can specify scenarios with within XUnit, within NUnit as well, for more complex things. So I'm saying here I create a collection, a null collection, and here I am returning my expectation. If I pass this null collection, I expect a single dot to be printed. Let's continue. So next expectation, single item collection. So also I forgot to include empty collection. So let's add that. IEnumerable dot empty int, and the result is also just a dot. Next is single item collection. So we will have a new like this, and I just write one. And my expectation is if I pass single item collection, I will get that single item. And lastly, to test this thoroughly, two items collection. So if I have 1 and 2, I expect 1 and 2 to be printed, and always a dot in the end. So if I pass two items collection, this is what I expect to get. And if I specify that this is my collection, or rather items, and if I specify this is my expected output, then I can basically say actual output. And why are you not finding that function? The string many, it exists. It should exist on items. It should exist, but it does not. I forgot to add static here, but that just solves half problem. Yeah, it's missing this keyword. That's a good point. So extension methods, they're not extension methods unless you add a this keyword. Without this keyword, it's just a static method and therefore needs to be called not so fluently. Without that this keyword, I would have called my function like this. But without it, I can simply call it like this. And thus, my assertion will be simply like assert. What do I expect? Equal. I expect expected output to be equal actual output. And that's my test for that extension method. And it does not work. Oh, really? Let's see. One, there is no space in between, but we would like that space. So let's add that space. Let's run the tests again. Now one is failing. What happens if it's null? If it's null, it froze right now. So I need to do validation. If this thing is null. Okay, if it's null, or if it's 0 items in it, or like this, if it doesn't have any items, then we return an empty string. In other words, we can simplify this by saying if this collection has no items, return empty. So if I run my tests now, they should fail because my expectation is slightly different. I don't want a dot now. I just want an empty string. And okay. Confused. Okay, I'm not sure why this is failing right now. Let's return to the dumber approach and let's see if it succeeds. It succeeds. Okay. What did I mess up? I guess it was still going for that execution, even if the thing didn't exist, if it was null, but so be it. Anyways, that's extension method. And that's how you use it to string many, we got our extension method. And, you know, um, I can apply this to any collection that I feel like. And that basically means that I'm creating my own LINQ queries. So if through extension methods you can create LINQ queries, do you think LINQ was built that way? And the answer is yes, indeed. LINQ is heavily basing itself on two things, IEnumerable and extension methods. So LINQ is really just a bunch of extension methods on top of IEnumerable. And like this, I can write custom LINQs. Cool. There are multiple different LINQ statements, like you can check if collection contains any items, you can use map with select, you can filter with where, you can find first or default and look up for a single item, and many more things. But it comes with, individual scenarios that will pick individual LINQ statements. But as long as you understand the fundamentals, that it's all based on extension methods, and that it works on IEnumerable, you're good to go. You're good to go, and you will find the lead eventually. So this is a generic, right? The last two things I wanted to show is dictionary and more about generics. So dictionary. Let's go to shopping list service. I have a design mistake in here. My shopping lists are in a list. How am I looking up shopping lists? Most of my shopping lists are being looked up by an ID. And if most of them are being looked up by ID, I'm making a major mistake right here. I am running a loop just to find something that matches an ID. In programming, there is an answer to that problem. When you have something that can be looked up, and that happens often, it's worth considering a different data structure. And a data structure that helps in our case is called a dictionary. So I will change this to a dictionary. And basically my shopping lists will return keys. So dictionary is a key value pair. Just like an array, you can use an index to access an individual value. But that index in a dictionary is called a key, and it isn't going in an incremented sequence. It can be completely chaotic, full of holes, because it uses keys, and keys can be anything. They can be objects, they can be strings, they can be the same integers if you so will, but they don't have to go in order. They don't have to be in sequence. They can go as they please, but the key point here is that if you are using a dictionary, you no longer need a loop, because a dictionary is like a table. You say, in this row, there is a value, and you just pop that value out and return it. Push that value out and return. Anyways, let's refactor stuff so that it works. So adding a shopping list to a shopping list dictionary this time involves specifying the key. I must specify a key next to a value. So my shopping list's key is obviously shopping list ID. And obviously dictionary needs 2 parameters. So it's an integer and a shopping list itself. Cool. Let's go on. So not keys, but values, obviously I want to return, because value is a shopping list. Oh, and now a really cool thing. This, right now, disappears. And it becomes this. Why? Well, first or default. Not quite, actually. This actually becomes more complex, but faster. And that's the essence of dictionary. So basically we say if shopping lists contains key of that ID, return shopping list at that ID. But if it doesn't, return null. That's basically a refactored equivalent of what we had before. Get by name, unfortunately, it will be dull, unfortunately. Not keys, but values. Remove shopping list is the same. I just need a key here because it removes by key. That's another difference between dictionary and list. Update shopping list name. Yeah, nothing is different now. So this last bit is the missing piece. So once again, I just need to say that we're not taking shopping lists, but we're taking values. Because shopping list is a dictionary, it also includes a key, and for select, that's not very useful. Cool. So the key point here is, I'm lost, is this bit. This is very fast. This is, no matter how big this dictionary will be, it will take near 0 time to get that shopping list by that ID, because it's constant time. It's always the same. Obviously, it will take some time, but it will be many times faster compared to doing a loop and finding it that way. Thus, it's a preferred way. Cool. So that is dictionary. So when should you use a list over array? Use a list over array in most cases, because in most cases we have collections that in their nature requires expansion or shrinking them, and therefore list is just more practical. However, if you have hard-coded values in local scope, array is unbeatable. It is the minimum you can use for a collection, right? It won't change, you don't care, the scope is small, so that's fine. If we think about return types, and this is a good example, we have IEnumerable. So also return IEnumerable where applicable, unless you need specifics of a specific data structure, like a list. If your intention is iterate through, IEnumerable discovers, exposes that intention the best. Because all you can do with an IEnumerable is to either refilter through it, like run a bunch of query methods for it, or just do a for each. Well, in a broad sense, for each is what you need IEnumerable for. That's it. If you need more, then choose something else. But if you don't, prefer that. The problem if you expose a list, once again, you give open doors through which you can break stuff. And we don't want to break stuff. We want to make its intention crystal clear. Right. So what did we cover so far? Let me have a quick look. We went through collections and IEnumerable. We went through generics, but we didn't go through generic constraints yet. Let me try and explain generic constraints. Policies. Shopping list policies. If we wanted to constrain this class, for example, to only take policies of a certain type, for example, fixed, we would need to add generic constraints to those. Sorry, I derped a bit. So if I do something like this, I basically say tax shopping list cannot mix tax policies within it. For example, that's not what I meant. That's not what I meant. Tax policies. For example, these tax policies, they all need to be of the same type. Let me just specify this thing. I will quickly delete this for a brief second. Copy this, undo this, and go back to mistakes. So, oh no. Yeah, right here. Great. And here we can say tax policy. So like this, I basically say that all shopping lists, tax shopping lists, must have the same tax policy in them. And I didn't add any logic for validation. I am doing this through design. No matter how hard you will try to fuck this up, you won't be able to because generics won't allow you to. Let me continue with this tax shopping list converter. Tax shopping list converter. It cries for this. And so I will add that right here. And obviously I need to specify that right here as well. What's wrong? It doesn't implement that, right? Okay, okay. Okay, whoops, like this, like this. So now I can basically specify different converters for different policies. For example, fixed text policy converter will come with this kind of converter. For example, and in every place I need to specify that. For example, like this. So, yep. And what's all this fuss about? So if I go to test, you can, for example, see that if I created a tag chopping list converter with fixed text policy, I'm no longer able to create different kind of policies. Well, what do I mean by that? If I specify a type here, it also requires me to pass that type, right? So if I specify a different type, progressive text policy, now it requires me only progressive text policies. And why is it unhappy? Like this. So with this approach, I, by design, enforce what I accept and what I don't. And naturally, you might ask yourself, so what is the breaking point when you should be using generics and when should you be using extension methods, right? Sorry, polymorphic functions. Polymorphic function, ones that use a base type versus generic types, ones that use a concrete generic type on a call. And the answer to that is prefer to use base types. Use generics only when you need a specific type. Somebody asked, is it going to be recorded? Yes, it will be recorded. It is recorded. And there's also written material in video description if you want. And there's also homework. So, yeah. Use generics when specific type is important. In our case, if we want to prevent mixing policies, generic time serves that purpose. In other cases, for example, an add method in a list, it is a generic class. I mean, the whole list is a class. It's a generic class that only accepts elements of the same type. It doesn't allow mixing types. Why is it beneficial? Because the type we added, the element of certain type we added to a list, we want to get that element back as well. And that's why it's beneficial. Because we don't need to do any magic like casting just to figure out, just to get to a point where it becomes usable. Generics allows us to make things usable without all that fuss, and that's why it's so useful. Collections are generic based, they are extension methods based, they are IEnumerable based. Do you have any questions? Because today is a short lesson like that. There isn't much to talk about unless you have questions. And I will go here. Let's undo a bunch of stuff. Questions, anyone? Cool. Shopping list controller. Yep, you don't need that. You don't need that. Cool. I'm lost. What is missing? Right. A bunch of things here. So I just want to mention you can add constraints with a where keyword, and it constrains that generic T, because otherwise that T can be anything. I wrote T at the start because T sounds for template, and it is a conventional way of specifying that the argument is generic. So if you find something like T item, that's generic. That is almost 100% for generic. But in other cases, you might find something like this, TGF, like just different letters and alphabet used for different generic types. You can have multiple generic types in a generic class or function. But it's a less preferable way. It's much harder to understand what T and G and F means over T item or and then T key, for example. Yeah. So that's it then. That's all I had to say for today. And in the next lesson, we will go through entity framework, code first approach, and the lesson after that will go through entity framework, database first approach. So we will learn a bit about databases, how to persist data, and how to do it in C#. So 2 more lessons until we fully move on to front end, to HTML, CSS, JavaScript, TypeScript, and React. So till that time, see you next week. Farewell.